A newborn cannot lift its own head. It has only limited control over its body temperature. It cannot chew a piece of meat or a handful of tough roots. And unlike the infants of other great apes, it has no thick coat of fur to cling to while its mother moves. Now put that baby in the Ice Age. The group cannot simply stay home. Food moves, seasons change, camps are abandoned. Adults still have to gather plants, maintain fire, prepare tools, find water, and sometimes travel long distances. Meanwhile, somebody has to carry a completely dependent infant through all of it. Cold is especially dangerous. A newborn's small body loses heat quickly. Food has to be soft enough for a mouth with no teeth, and for months the baby cannot even move itself away from danger. So here's the real question. How did a species whose babies are this helpless survive for hundreds of thousands of years without modern nurseries, formula, strollers, or hospitals? How did enough of those babies survive to become us? The first answer is almost embarrassingly simple. Someone picked them up. Among many hunter-gatherer societies studied by anthropologists, infants spend enormous amounts of time in close contact with adults. They are carried in arms, held against the body, or supported with simple slings and wraps. We cannot dig up the first baby sling. Soft materials rarely survive for tens of thousands of years. Later prehistoric images and figurines may hint at forms of infant carrying, but they cannot tell us exactly when the practice began. What ethnography does show is how useful close body carrying can be. It keeps an infant secure while an adult moves. A sling or wrap can also free the carrier's hands for food, tools, firewood, or other work. And there is another advantage: heat. Human newborns are actually relatively fat compared with the newborns of many other primates, but that does not make them safe from cold. Their small bodies still lose heat rapidly because they have a large surface area relative to their mass. Holding an infant against a warm adult provides an immediate thermal buffer. Later, controlled fire, clothing, bedding, and constructed shelters could add more layers of protection. By the time modern humans were expanding into some very cold environments, survival was not based on one solution. It was a system. Body heat helped protect the infant. Fire warmed the living space. Shelter reduced exposure. Clothing and hides could slow heat loss, but that only creates another question. Why does a human baby need so much help in the first place? A newborn chimpanzee is dependent too, so is a gorilla. But human infants are unusually immature in several important ways. Researchers sometimes describe this condition as secondary altriciality. A large amount of human brain growth still lies ahead after birth. For decades, one famous explanation focused on a difficult evolutionary trade-off. Our ancestors began walking upright. The pelvis had to function efficiently during bipedal movement. At the same time, our lineage evolved increasingly large brains. Giving birth to a large-headed infant through a pelvis shaped by these competing demands looked like an evolutionary problem. The classic idea was that humans partly solved it by giving birth relatively early in development. The baby would then complete much more of its development outside the womb. That explanation is still influential, but it is not the entire story. Researchers continue to debate exactly what determines the timing of human birth. Maternal metabolism, pelvic anatomy, the mechanics of childbirth, and other evolutionary pressures may all matter. So it would be too simple to say that walking on two legs forced humans to give birth early. What is clear is the result. Human infants arrive with an extraordinary amount of development still ahead of them. And that creates another survival problem: food. A newborn does not need to hunt, but someone has to produce enough energy to feed it. For the first part of life, the solution is milk. Chemical signatures preserved in ancient teeth and bones can sometimes help researchers reconstruct patterns of breastfeeding and weaning. In a number of ancient populations, those patterns indicate that breastfeeding continued well beyond the first year. In some cases, the transition away from breast milk extended into the second or third year of life. The exact timing varied between populations. But prolonged breastfeeding makes sense in a world without commercial infant food. Breast milk provides calories in a form an infant can digest. It also contributes important immune protection during a period when infections can be especially dangerous. Eventually, milk is not enough. Children need other food. But the adult diet is not automatically a baby diet. Tough plants, dried foods, and large pieces of meat are difficult for a young child to process. Adults can solve that problem mechanically. Food can be softened. It can be crushed. It can be mashed. It can even be pre-chewed before being given to a child. None of those solutions requires specialized technology. They require time. And that creates the next problem. Human children stay dependent for a very long time. Carrying them costs energy. Feeding them costs energy. Watching them costs time. Protecting them costs attention. And breastfeeding itself is biologically expensive. For a mother trying to survive in a demanding environment, one dependent child already represents a major investment. Yet humans eventually developed a reproductive pattern very different from that of our closest ape relatives. Wild chimpanzees commonly go 5 years or more between surviving births. In many human foraging societies, birth intervals can be considerably shorter. That raises a strange question. How can humans support more dependent children at the same time when each individual child requires so much care? One possible answer changes the entire story. The mother was not necessarily doing it alone. Anthropologists studying foraging societies repeatedly find people other than the mother contributing to childcare. Grandmothers help, older siblings help, fathers can help, aunts, uncles, and other relatives help. In some societies, even unrelated members of the group contribute food, supervision, carrying, or protection. This pattern is one reason researchers have proposed the cooperative breeding hypothesis for human evolution. The idea is not that every prehistoric society organized childcare in exactly the same way. We cannot observe a Paleolithic camp directly, but humans appear unusually dependent on networks of care compared with many other primates. That changes the economics of childhood. If one person does not have to provide every calorie, every hour of carrying, and every moment of supervision, raising an extremely dependent child becomes more manageable. A mother can gather food while someone else watches the child. An older sibling can carry a younger one. A grandmother can contribute food. Another adult can keep a fire going. The child is still helpless, but the problem is no longer being solved by one body. It is being solved by a group. And this may be where the weakness of the human infant becomes something much more interesting. Being born with so much development still ahead is expensive. It requires years of protection. But it also gives the human brain an unusually long period in which experience can shape it. A child has years to absorb language, years to watch other people, years to learn tools, foods, dangers, relationships, and rules. Human childhood is not simply a long delay before adulthood. It is an extended learning environment. And that environment is social. A child learns not from one person, but potentially from many. So the trait that made human infants extraordinarily difficult to keep alive may also have increased the importance of cooperation, teaching, and social learning. That does not mean helpless babies caused human social life. Evolution is rarely that simple. But extreme infant dependence and extreme human cooperation fit together remarkably well. One helps make the other possible, and none of this means prehistoric childhood was safe. It was not. Early life mortality was substantial in many ancient populations. Disease, injury, malnutrition, cold, and accidents could kill children despite enormous effort from the people around them. That makes some archaeological discoveries especially powerful. At Arma Verana in Italy, archaeologists uncovered the burial of an infant girl who lived roughly 10,000 years ago. She was buried with shell ornaments and pendants. Those objects represented time. Someone had collected them, someone had worked them, someone chose to place them with her. At Sungir in Russia, much older burials of children contained extraordinary numbers of carefully manufactured beads and other grave goods. Archaeology cannot tell us exactly what those people felt. It cannot measure grief. But these burials do show something tangible. People invested substantial labor in the treatment of children after death. Even in populations where losing a child was a real possibility, young lives could receive extraordinary attention. And that brings us back to the helpless baby. At first, it looks like an evolutionary disaster. No claws, no fur to grip, no ability to walk, no ability to feed itself. Years away from independence. Placed alone in a prehistoric landscape, a human infant would have almost no chance. But human infants were not supposed to survive alone. That may be the mistake hidden inside the question. We look at a helpless baby and ask what special adaptation kept it alive. Maybe the more important adaptation was all the other humans around it. The equipment has changed. Today there are insulated houses, modern baby carriers, formula, medicine, and heated rooms. For most of human history, those particular technologies did not exist. What existed instead was body heat, breast milk, simple ways to carry and soften food, fire, shelter, and hands that were not always the mother's own. A human baby may be one of the most helpless newborns in the animal world, but it was born into something just as unusual, a group of humans. And for our species, keeping a child alive may never have been a one-person job.